Welcome back, happy developers. The last episode ended a little abruptly as we were in the midst of having fun with function blocks. Function blocks are our first steps into the world of object-oriented programming, and thanks to them we can combine state with behavior. I promised to talk about something called interfaces, which is what I'll do now. Interfaces are a really neat thing. They can at the first glance look a little weird. I remember when I came across interfaces the first time, I think it was when I was programming in Java in the early 2000s. I thought they were just an abstract annoyance. But once you understand the actual advantage of programming by interfaces, it will all make sense. Let's get started.
In the previous part of this tutorial, we introduced the topic of inheritance, where we learned that a function block could inherit some of the properties and functionality of another function block by extending another function block. Just as with inheritance, interfaces in IEC 611-31-3 is a mechanism to achieve abstraction. Interfaces are one way to achieving one of the pillars of object-oriented programming called polymorphism. Polymorphism is the abstract concept of dealing with multiple types in a uniform manner, and interfaces are one way to implement that concept. Interfaces specify what the function block must do, but not how. It is the blueprint of the function block. An interface is about capabilities. Imagine a chessboard. Every player on the chessboard may be an interface, and any function block, which could be any of the players like king, peasant, etc., implementing the interface player must be able to move. In other words, it needs to implement the interface move. The interface specifies a set of methods that the function block has to implement. You can see it as a binding contract. Anyone implementing an interface must follow the contract, that is, implement the methods in the contract. An interface is defined using the interface keyword. In this example, we have an interface we call iLightTower. With the interface, we describe the behavior for anyone that will actually implement the interface. One behavior might, for example, be that it's possible to power on/off the light tower. That is to enable the LEDs of it. Another one might be to set the color of the light tower, such as red, blue, and green. One additional one might be to enable or disable a buzzer or beeper of some kind. These all three methods describe some of the behavior that all function blocks that implement this must follow. Now let's imagine we have an actual implementation of the interface iLightTower that is specific for the company's Baluf light towers. The FP_Baluf_light tower is one type of light tower that has an actual implementation of the interface. Baluf is just one manufacturer of many, and the Baluf one might have an implementation that differs from the others. Another manufacturer that might do light towers are SICK, and then this goes on. There might just be many manufacturers doing light towers, although all of them share the behavior that they have a way to turn them on and off, set the color of the individual lamps, and also a possibility to set a buzzer. They all implement the same interface I_LightTower. In other words, they all share the same behavior. The actual implementation of these, however, might differ. One might use simple 24-volt digital inputs, while another might use some more elaborate protocols such as IO-Link or ETCAT for communication. To create an interface, we need to use the keyword interface, and then we just add methods to the interface as we would add methods to a function block. Then we need to create a function block that implements that interface, which we do by using the keyword implements. By saying that we will implement the interface I_LightTower in our function block Baluf_LightTower, we are assigning a contract that we have to implement all methods that are in the interface iLightTower. So we need to add the implementing code, that is the code that does the actual work of power on the light tower, which of course could vary between manufacturers. For some it might be a simple digital output to enable it, whilst it for others might involve complex serial protocols. When using a function block that implements an interface, you just declare it as you normally do. So here we have two different light towers, one from Baluf and another from SICK. We can then declare an interface and assign it a function block. In this case, we just assign it the Baluf light tower. This means that if we call the interface, the actual implementation that will be called is the Baluf one. The nice thing with interfaces is that we can change the actual implemented function block of the interface during runtime. So here we just reassign the interface to the SICK light tower. This is possible because both function blocks implement the interface I_light tower, and thus both function blocks have agreed on the contract to implement whatever behavior is defined in the interface. To call a method, you call it as usual. To create an interface in TwinCat, right-click on POUs, select Add, and select Interface. This will create this pop-up window. Enter the name of the interface, in this case I_light tower, click Open. This will create the interface. Now you can add your methods to the interface.
Now you might be wondering, but why do I need interfaces? Why can't I just skip them and just directly create a function block that has all the methods I need without it implementing any interface? Why can't I just use the concrete function block directly? I mean, with inheritance, by extending another function block, I at least got a lot for free. But with interfaces, don't they just make life harder for me? No. There are a number of reasons why you want to use interfaces. Interfaces happen when you want to describe in abstract terms what an object is supposed to do, but don't want to tie it down to a particular implementation or function block. So in the example of the light tower, at the time of writing your code that uses the light tower, you might not actually care exactly how the light tower works and how it executes its different functions as setting a certain color. In your code that is using the light tower, you just want to set the color. This also means that we can develop parts of the software without knowing exactly how other parts work in detail. Which leads me to the next point. It makes it easier to work in teams. Now imagine Team A develops some software that runs on a machine, and Team B develops some software to do some file logging of events, for instance to a file or a database. The only thing Team A needs to know from Team B is an interface to write events. Team A doesn't need to know exactly how the persistent logging is being made. They don't even need to know whether it's written to a CSV file, an XML file, or a database. They just need to know that there is the interface that has a method log event, which describes the intent, not the actual implementation. Thus, Team A and Team B only need to agree on the interface, the contract between each other. Then both teams can develop their software separately and independently, and then just have an integration phase much later. The third point is tests. When writing tests, you will find that concrete classes will not work well in your test environment. If you, for example, have a function block that depends on a database function block, your unit test will not run in your test environment. The solution is to use an interface and mock that interface so you can test your function block. The key point of interfaces is that they provide a layer of abstraction so that you can write code that is ignorant of unnecessary details. In IEC 611-31-3 and structured text, we have the luxury to have an explicit keyword interface to achieve this. This is, however, not necessary to achieve polymorphism. There are other ways to do this, and in more dynamically typed languages such as Python, this is usually what is referred to as duck typing. What this basically says is that if something walks like a duck and quacks like a duck, then it is a duck.
A difference worth mentioning between interfaces and inheritance is that a function block can only inherit one function block, but it can implement as many interfaces as it wants. So here we have a function block, and this function block can at most only extend one additional function block. However, with interfaces, a function block can implement as many interfaces as it wants. This means that if we had a function block that implements two interfaces, interface X and interface Y, it would have to implement the three methods in interface X and the one method in interface Y. The syntax for implementing more than one interface is to simply add a comma between the interfaces that you want your function block to implement.
Alright, I think it's time for us to do a little bit of coding. So I was actually thinking that we will continue with the example that we did in the last part of this tutorial. So we'll continue with exactly the same project that we did. And we will add some functionality. So we'll start with creating a shell for storing our events persistently. What I mean persistently is to store them to some sort of persistent storage. So to a file, to a hard drive or a database or something alike. And we're going to make this very flexible by using an interface. So we're going to say, okay, that we want to store our events, but we don't specify in exactly which format, whether they're going to be in JSON format or XML or in an SQL database. We just want to provide an interface to, hey, here I have an event and I want to store them persistently. So we're going to create an interface for this. So, and there are various ways to do this, and I'm actually thought about doing it in a way that we learn a little bit more here about stuff. However, we will not implement the actual storage. That we will do in the next part, because we're anyway going to have to go through state machines and other things that we're going to need to do this. Okay, and if you remember here from the last part, we have our event logger that takes care of the actual event. So in a very good event logger here would, for example, take care, right now we only have this array of, I think it was 100 events. And everything is stored in here, and this takes care of all the events. We could of course extend this functionality by making sure to use a ring buffer, so the oldest one is always removed once you reach more than 100 events. But that's the core functionality. That's the responsibility of this particular function block, event logger. But then we don't want to put the functionality of storing the events persistently in this function block, because again, we want to separate the concerns as much as possible. We want to make this code as modularized as possible. And I think, what I want to point out here is, as a PLC developer, I want you to get into this mindset early, because I think, again, we had all this development of software engineering during a very, very long time, and it's just been shown over and over again that the software is just much more maintainable, and you're going to save tons of time if you try to separate the concern as early as you can. So that's what we're going to do. But to do that first, we need to provide some interface. So my idea is here that we will still have this code add event, but once an event is added, so again, once an event is added into the event logger, then we write the event to the persistent storage through an interface. But it's actually not the event logger that will write the persistent data. For that, we will have individual function blocks for whatever format that we want to store in. So if you want to store on a file in XML format, we might have a function block that we call XML file storage logger. And if you want to store in JSON format, we might have one that's called JSON file logger or whatever. And if you want to have a database, we can have a database logger. The important thing is we will at some point, of course, need this concrete, not classes, but function block that implement a certain behavior. But the event logger doesn't need to know. This particular event logger actually doesn't need to know how this is how all of these particular implementations are gonna look like. It just needs to know, hey, I have an event here and I want you to store it. Okay, so we need an interface to describe this, and the easiest way here is to just create an interface. So now we're gonna create our first interface, and we can call this persistent event storage. So any function block that wants to have where you want to do persistent storage needs to implement this interface. And when you create the interface, it's just an empty shell, right? So you only have something that's called interface, and this doesn't do anything. It doesn't do us any good. And so we need to write our first method. And the thing we want to do here is basically just to write any event to the persistent storage. That's the interface, right? What do we want to provide by this interface? What we want to provide is the event. So we say, hey, take this event. I mean, the event will have all the data already in it. It will have the correct timestamp and everything, because the timestamp was created from our event logger function block. So the whole event is ready to be written to the disk, but we still need to provide it to the interface so that the concrete function block that actually implements the interface will have the data. So for this, we create a method. So again, kind of think of the method is the behavior, right? So what should it be able to do? Yeah, it should be able to store the event. So we can call it store event. No return type. And the input data is the event. I think, however, what we had was we created a structure for this. Right? Yeah, so we had a structure. And the reason we didn't have the structure in add event was because we didn't have the timestamp at that point in time, right? So we needed to provide everything except the timestamp, because the timestamp was created here in the function block event logger. But we don't need that anymore now because we have the timestamp. Okay, so the event logger will have the whole structure ready for us. So in this store event method, we can just provide the whole structure, the whole event, that is, like this. So we have an interface, and that interface provides the service or the behavior of storing events. And if you call store event, whatever one is implementing this interface, again, if it's the XML logger, JSON logger, database logger, there's probably a bunch of other formats, other ways to store data, of course. But whoever implements this will have to implement this particular interface store event that describes what it's supposed to do. Okay. So we have our interface ready. Now I'm going to learn you something new that I usually use a lot when designing my software. So again, right now we haven't written any actual implementation code, but that doesn't mean that we can't already start to code how our software is supposed to behave. And what we do here is that once an event is added, we will have the whole structure here. So the structure as the event is available. Is that here we want to store the, I mean, this is just one way to do it. Of course, you can store this somewhere else, but one way to do it is here we want to store the event persistently. That's a tricky word, persistently. Yeah, that's about right. And to do this, what we need to do is to have a reference to this interface, right? So we need to have a reference to the interface, and whoever implements that interface, it's not our concern. We just want to describe the behavior of our software. That is, we just want to have access to the interface. So I kind of like to think this: how would I do this if I was in team A and another guy or girl was in team B? You know, we need to have some interface to talk to each other. That's a good way to design software. You know, just try to minimize the direct dependencies between each other. All right. And to do this, we need a reference to this interface. And one way to do this is by something called dependency injection.
Dependency injection is a technique in which an object receives other objects that it depends on. These other objects are called dependencies. The injection refers to the passing of a dependency into the object that would use it. Let's imagine we have a function block that takes care of the complete state of the machine. So it knows whether the machine has stopped, is running, and whether it has any active alarms. Part of this information could be forwarded to a light tower. So for example, if the machine has stopped, the light tower could be red, and if it has alarms, the light tower might be yellow, and we might want to give off a sound using the buzzer to indicate that attention is needed. However, the state machine function block should not have to take care of actually enabling the LEDs and the buzzer of the light tower. For that, we should have a separate function block that does the communication with the light tower. What we should do next is to inject a dependency to the light tower. This means that when we instantiate the function block fb_stateMachine, we inject the dependency of the light tower. By using an interface as injection, the function block fb_state_machine doesn't need to know exactly how the light tower works, only that it provides a certain service, in our case that it can turn on and off and set a certain color of light, etc.
Alright, now that we got the theory for dependency injection, we're going to do it. And that's achieved by creating something called the fb_init method. So we add a method, and here we actually get some default methods. I'm not going to go through them right now. The only important thing here now is the fb_init method, which will be called when the object is instantiated. So whenever there's an instance of the event logger function block that will be instantiated, the fb_init method will be called implicitly. So you don't have to call it explicitly, that is, you don't have to call fb_init, it will be called implicitly. And here we can define some default behavior, some stuff that you want to put in there that's going to be executed once the function block is instantiated. So what we want to do here is that we want to provide an interface, a reference to this interface of persistent storage. And this interface is, so this is basically doing the dependency injection. So we want to have our reference to this interface coming in here. So you need to provide basically whenever this object, whenever an instance is created of event logger, you need to provide what more data do you want to should go in here. And in this case, we want to have a reference to this persistent storage interface. And the nice thing about this is that it's a reference to the interface, but in the background, it can be the actual implementation function block can be any of these function blocks that do the actual storage. So we provide reference and call it persistent storage, persistent event storage, like this. And then we need to store it locally, so we always have the reference locally in the function block. So first let's create a local reference to it. We create a local reference to it in the function block variable definition. So what I usually do is I add an underscore to everything that's coming in from as a dependency. So what as a dependency? So as something coming in from the outside. And I will call this just persistent storage, persistent event storage. Yeah, that's the interface persistent event storage. Okay, so now the whole function block has a reference to this interface. And this one in the fb_init method, that's the one we want to store. So we will what we're going to do here is basically when we create the event logger, we will have to provide it an interface. So a reference to this interface, and then we will store this reference that's coming in here locally in the function block. So all the methods in the function block have access to it. Okay, so that's quite a neat thing. And now the nice thing here, again, I want to really point this out, that when this function block is created, this is just an interface. So it only describes the behavior, right? So if you look at this interface, it only describes that there's a method store event, but it doesn't actually describe anything about how this is done, exactly how this is implemented. So again, whether it's done by JSON, XML, or whatever, it's not described here. And that's the important thing here. We don't care, because in the add event, we just want to store it, and how that's stored and how this code is working it's not anything of this function block's concern. Because again, we want to separate the concern of the function blocks. We want to modularize them as much as we possibly can, because of all the advantages. So it's going to be easier to test and everything and extend and yeah, whatnot. So now we have persistent event storage reference in the function block. So when we do the add event, we can actually call this. So we can do persistent event storage. So again, this is the trick. I just want to show it. Instead of writing persistent blah 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 blah, you can just write the first one, then control and space. This is the magical trick. I would encourage you to learn it. And dot, and then we have code completion here helping us out and saying you can call store event. And then we need to provide it with the event. And the event is in the here. It's in the buffer of the events on this particular position. So we just, because this event buffer is just an array of events, and we want to persistently store the one that's on this position. Oops, that's a mistake. Excuse me. And that's it. And this is all the code needs to know. This event logger function block doesn't need to know anything about how this is actually stored. That's done by whoever is implementing this interface. Okay, you save that. And now the next thing is here. Okay, if we wanna create, if we wanna try to compile this now, we will get an error, because when this function block is created, the fb-init method requires us to provide a reference to the interface, right? So if you try to compile this now, build solution, it's gonna say no matching fb-init method found for instantiation of event logger, and that's exactly what it means. There's nothing provided here. And the way to do this is that we actually need to provide a concrete implementation. So we need to provide it an interface, but this interface actually needs to point to something that does the work. So we need to provide a reference to a function block that actually does the implementation. And what I'm going to do now is that I'm just going to create a shell for a function block that implements the interface without actually doing the implementation, as that's going to have to wait for the next part. So I'm going to add a POU. I'm going to add a function block, and whatever format we can do, XML persistent event storage maybe. And here is actually a thing. You can actually select implements here already when you create the function block. So you can already hear the integrated development environment. Twinket already helps you with this functionality. Then you can select implements and select the interface. So this is the interface we want. We want the function block XML persistent event storage to implement the interface I persistent event storage. And we want it to be in structured text and open. And that's the nice thing here. Now we got an empty shell for a function block that implements this interface. And what it also did for us automatically when we did this was that it added the store event method in this new function block for us. However, if we click on the store event, we actually get a warning here that says warning, add method implementation, which is what it is all about, right? Because the interface is just just describes the behavior, nothing about the implementation. It just says that you need to have a method store event that has this as an input. This method, the actual implementation, needs to have the implementation done. So that's the warning. So if we would compile this now, we're gonna get a warning, not just okay. So we don't get that warning because we don't use it yet. Okay, let's wait a little bit. However, I'm not gonna do the implementation, but here is where the XML writing is supposed to be done. But we're not gonna do that, not in this part. But just imagine that we have done it here. And the important thing here is that now we have a function block that implements this actual interface. And what we can do now is that we create an instance of it. So like this, we create an instance of FB XML persistent event storage, a function block that implements the interface that we described, that implements this particular behavior of being able to store events persistently. And now we can provide a reference to this one. So we can do like this, and this is how you do it, by the way, how you provide parameters to the constructor. So for anyone, by the way, here that's used to Java or C++ or any other object-oriented programming language, the fb-init method is basically
equivalent to constructors. It's not exactly the same. There are some differences, which I'm not going to talk about. There are some slight differences, but principally, from a principal perspective, it's the same thing. The obvious difference here is that you can only have one FBinit method. You can't have several, like, you can have several constructors with different parameters in Java or C++. You can't have that here. But that's for anyone that's doing traditional programming, that's it. So we provide this to the FBinit method, this reference, and because this one implements this interface, it's totally valid now for to do this, because in the FBinit method, this is going to be called now. So we're going to get a reference to something that implements the iPersistent event storage interface, which in this case happens to be the XML storage. But it could be anything, right? So it doesn't have to be XML, it can be the JSON, it can be a reference to some SQL database storage, whatever, your fantasy sets the limit. And the nice thing and the really nice thing here is that you can actually in runtime change the storage, right? So it gives extreme flexibility that the event logger can use the XML storage, but it can use any other storage as well. And the event logger doesn't care. The event logger doesn't have to care. The event logger, the only thing it cares about is that it stores an event, but it doesn't care whether it's stored in a database or whatever. And it shouldn't care. That's the important thing here. It shouldn't care, because if it cared about exactly how the data would be stored, then we would have this tight coupling, and that's really not something you want to strive for in software development. And believe me, you're gonna save a lot of time and a lot of frustration, and especially if someone else is gonna take over your software and do software maintenance on your software 10 years from now. This software architecture, a good software architecture, is going to help that next person a lot. So with this, we should be able to compile, like so. Now we actually get this add method implementation. So I'm going to press cancel. I just want to show you. If we click here, we actually get this. So the compiler actually warns us that, hey, you haven't actually done an implementation of this function blocks, which you should, right? Because this is the implementing function block that implements the interface, and this one needs to have all the magical code here. So we get a warning. But anyway, it compiled and we can run it, but nothing is going to happen, of course, because if we add an event and this is going to be called, and because we have a reference, this persistent event storage will be a reference to the XML storage through the constructor that was provided. It's going to be calling the store event here. However, this one doesn't do anything right now. We will have to wait for this to do this in the next part of this tutorial. Now we have reached the end of this part. Just as with the previous part about function blocks, I want to point out that we only scratched the surface of the possibilities of interfaces with this part of the tutorial. Interfaces are so much more than just writing implements and implementing an interface. By using interfaces, we can design our software in a much more modularized way, and by utilizing certain design patterns, we can make our software much more robust. When doing our software design using test-driven development, which is a coming part of this tutorial, we don't have to worry about the implementation specifics in the beginning of our project, but more architectural concerns. By thinking in this way, we will end up with software modules that have clearly separated concerns, high cohesion, and loose coupling, which are all desirable properties of software. Decades of service in software projects have shown this over and over again. Software engineering is my biggest passion in life, and I could talk about this particular topic for hours, but then this would no longer be an introduction tutorial. I'll get back to the topic of interfaces more, especially when we start to talk about test-driven development in the more advanced parts of this tutorial. Thanks for sticking around, and see you in the next part.